Good day, everyone. Uh, I would like to take you through my project, the project for the MIT808 course. So this project is mainly focused on enabling the weather-based decision making for forestry research and management. So as an introduction, so the Institute of Commercial Forestry Research is a custodian of this weather data on behalf of the forestry industry. And so this data set consists of the daily minimum temperatures and maximum temperatures together with the rainfall from 1950 up until the present moment. So part of the database, which is from the 1950 up until 2007, it was stored in a user-friendly application, but however, it's now obsolete. So the remaining data sets are also stored in a text files, which currently cannot be accessed or visualized by the potential users within the research who want to do the research on this field. So then the aim of this project is then to develop a web-based app where now a user will be able to interrogate the data or be able to also visualize it and also retrieve or the data or download the data for whatever purpose he or she wants to achieve. So the application functionality here it should be a accessible through the easy access through the web and be able to really perform the visual exploratory data analytics and also the predictive analytics. So in terms of the methods, we collect that data from 1950 up until 2019, so which in total is 107 million observations. So these observations are coming from 6,352 weather stations. So we perform the visual data visualization based on the selection of the weather station and also the prediction of rainfall and also the minimum and maximum temperatures using the extreme gradient boosting algorithm and also the random forest algorithm. So we perform also the hyperparameter tuning for this algorithm to ensure that we obtain the best performing model as possible. So we then deploy this visualization and also the modeling part using the Streamlit app in Python. So in terms of the results, these are just the summary of the stations that are in the data set. So you can see that the data set is dominated by station that measures the rainfall only. So in terms of the prediction accuracy of the model, so we consider the base random forest model, which we can just use a random parameters, then which is the number of estimators. Then we also tune these models or using the by reducing the number of predictors, and also then we use the randomized grid search um, to find the best parameters for this random forest model. Then we also do the extreme gradient boosting model. So as you can see here, this result shows that the extreme gradient boosting algorithm has comparable accuracy with these other random forest models. But however, it has an advantage because the runtime for this model is very much slow compared to the other one. So that's why then we can recommend that this model be be selected. But however, the user is able to really just select between the extreme gradient boosting or also the best random forest. So these are just the results from this stations based in Gauteng province. So you can see that the extreme gradient boosting has the mean absolute error of 2.669 and also the root mean square error of 3.43. So you can see that this model is performing better than the random forest. So this model then it also have the best advantage because in terms of the runtime and also the accuracy is comparable with other models. So as we already indicated that we deploy this these models, then I'll just show you how it was done. So this is just the Streamlit app where it will go through you can perform the predictive analytics and also the exploratory data analysis. So if a user decides to say you want to perform the predictive analytics, these are the options available. You can select the province where you want to do the predictive analytics and also the type of stations. You can also select the response variables and also the period where you want to do your modeling. And then it can also ask the user to ask whether if you want to use the engineered features, because we decided to include the month and the year as additional features in the model. So you can see here, these are the results from this algorithm, which is the external gradient boosting. So this now model, then at least it performs better as indicated previously in the summary of the performance. So the user can also be able to really just select the random forest model. So once you do that, select that option, then the app will run on that algorithm, and then the results then will be able to pop up in the app. So these are the results for the random forest algorithm. So in short, this is how the app works. And thank you very much for your attention.